Hello, everyone. This is Lee Markum, and I'm going live today to talk to you about 3 keys to SQL Server performance. So the first thing is that SQL Server must be able to cache sufficient data in memory. Now, SQL Server is a bit of a mystery to some folks in terms of how it uses memory, and people will go on to SQL Server maybe because they got an alert from a system from monitoring, or just because they're curious and they're poking around and they'll see that it's using 80% of the memory and they think that's a problem, and they look and it's SQL Server that's using all that memory. And they might actually go Google that and find out how to lower the memory usage for SQL Server, and they'll make a change and make things worse because they don't realize that SQL Server isn't like other applications, and it uses and needs memory in ways that other applications do not. So you need to be able to get data cached and keep it there in memory for SQL Server to work properly. And this is related to setting the max memory server setting. So there are a few different ways to do this, but essentially what this does is it controls the amount of buffer pool memory that SQL Server uses to store things like execution plans, data pages that it reads from disk that it might need in order to satisfy queries. So the first way that you can do this is just go into the server properties and memory page in SQL Server Management Studio and make the change manually in there to an appropriate value. The other way to set max server memory is going to be with spconfigure. The last way, which is kind of the easy button in my opinion, is to use the set-dba max memory command in PowerShell from the DBA tools module. What this does is it actually uses best practice information from a number of sources to help you have an easy button to execute this and set the max memory at something that is an appropriate starting point for each particular SQL server that you might run this command on. There is a way to see what it's going to do before you actually run the set. You can do get-dba max memory, and it will tell you what it's at now and what the recommendation is that it's going to set it to. So the next thing that is a key for performance for SQL Server is going to be being able to get data from disk in an efficient manner. And one of the first things that I would encourage people to do when trying to assess this sort of thing is look at your weight statistics. If you see parallelism and page IO latch type weights that are prominent in those weight statistics, that could be a good indicator that your SQL Server is burning up CPU, reading information off the disk to get it into memory in order to satisfy your queries. And if you see a lot of that and things like page life expectancy and some other counters are out of kilter or out of balance, then you may need to, again, go back to that previous step and revisit max server memory. You might have shifts in query patterns that are leading to poor indexing and high disk IO. Your application team might have refactored some tables for an application or built new tables for an application, and maybe they missed indexing some things. Maybe reporting queries or just the way people are accessing your data over time changes because they're interested in different things. And so now they're querying different kinds of columns in order to get the data that they're interested in. And all of these things can combine and lead to poor indexing and high amounts of CPU, parallelism, doing large table scans to get data because your indexing isn't sufficient anymore. So what's the answer here? What do you do in order to try to alleviate this issue or this problem? One of the first things that you can do is just look at SPBlitz index and look for ways to consolidate indexes. You're probably going to get some missing index recommendations, and you can take a look at those missing index recommendations and the existing indexes that you have and maybe merge some of those together into indexes that make more sense. A lot of times I see when I run SPFlit's index, there's over indexing, which also is going to hurt your performance. And so if you can consolidate down and have just the indexes you need, then SQL Server isn't maintaining extra indexes that aren't really used and aren't really being efficient for your particular queries. Another way to look at that situation and investigate is using the sys.dmio virtual file stats. So what this does is it gives you the IO information, latency, and some other information about IO from the perspective of SQL Server. And if you have latency over, say, 20 milliseconds, that's really not that great. And probably you have a problem that you might want to investigate. It doesn't mean that specifically that there's a storage problem. You just might be putting too much pressure on the storage that you have because your queries are inefficient, your indexing is inefficient, or you don't have the right memory settings. The other thing that you can do is check the IOPS and throughput on your storage, especially if you're in cloud. So if you're doing things like using AWS EC2 instances where you have elastic block storage, or you're on Azure and you're using virtual machines there, and the Azure storage, it has IOPS and it has throughput settings that you can adjust up and down. And you need to make sure that those settings are appropriate and that the VM that you're using isn't also part of the problem, because the VM, the EC2 instance in AWS, also has its own limits that you have to look at and make sure that you're not up against as well. So the third key for T-SQL performance is just avoiding T-SQL anti-patterns. And this list could be really long in terms of what can we talk about what to avoid. So I'm going to give you some names here at the end that you can look up to get some more information. But the first thing I'm just going to mention here is just non-sargeable predicates. These are things where you're doing functions and where clauses that cause SQL Server to not be able to use the indexing that you had so carefully crafted. And when that happens, again, you're doing large table scans, you're burning up CPU with parallelism and the page IO latch weights, trying to get data off of disk because your predicates in some cases aren't sargeable. They can't be used to search an index. Another T-SQL anti-pattern to avoid is just overuse of cursors. I'm not completely anti-cursor. I know this is a hot topic in the SQL Server world, but SQL is set-based. It works on sets of data, not individual rows. And when you tell it to process row by row, one at a time, and you do this quite regularly, you're working against yourself. You're working against what SQL Server does best. And so just think thoughtfully, think carefully about your use of cursors. In a similar vein, scalar UDFs can hurt you. You pass values into a scalar UDF, and it does some processing. If you pass, 100, 200, 50,000 values into user-defined functions, and it has to then go process all of that, that's not set-based. And so that's another thing that you want to think about and be aware of and monitor the usage of, so that you're not overusing scenarios that actually work against how SQL Server works. I told you I'd give you some names for this particular category. If you're interested to look more in T-SQL anti-patterns, great people to look up on the internet are people like Kendra Little, Eric Darling, and there are some great T-SQL books out there that you can buy to help you find those landmines in your T-SQL that might be hurting SQL Server performance. This information that I'm sharing is a summary of the URL that's on the screen. So if you're interested in more information and some of those links out to the other resources, please go ahead and visit that site. And certainly come out to leemarkum.com/blog for more information like this that will help you with your SQL Server. And that's all I have today for 3 keys to SQL Server Performance. And I hope everyone has a great day.